Hello everyone. So in this video, I'm going to cover some different cases and some different types of repetition beans. So let's begin. So just to recall back from my previous video, I'm writing this functional coverage for a very simple buffer design. Both the input and output are of 7 bits. And here is my test bench in which I am writing the cover point only for the signal A, which is the input. And in the previous video, I wrote some sequence or some transition beans, and I also provided the respected stimulus to record or get a hit for those beans. And in this video, I will be covering some of those repetition beans. And I also have a for loop in which I am providing a stimulus and I am doing a regressive check and I am providing all the possible values for the signal A. So let's begin with the repetition beans. So the first and the simplest kind of category is the consecutive repetition, in which a single value will transition to the same single value for multiple times. And to do that, you just have to write it like this. So first I will name my bin to be bin B4, and then let's say I want a value which is 16, and I want my signal, my variable A to transition to 16 for, let's say, 6 times. So this particular bin, which is bin B4, will record a hit when there is a transition to 16 for 6 times in a row. So it will be like that 16 is transitioning to 16, and then it is transitioning to 16 again, then again, then again, and then again. So it will only record a hit when the signal transition to 16 for 6 times in a row. So I will just comment this. So this is a consecutive repetition. And I will just go ahead and provide the respective stimulus, which is that A will be transitioning to 16 for 16 times in a row. But there's a catch here in my code, and it is because of the fact that I am using an event list uh, as a sampling check. So this particular cover group will only trigger when it detects any change in this signals. Those signals are the input A and the output Y. So let's just go ahead and provide the value of 16 for 6 times in a row. Six. So let's go ahead and simulate the code. Oh, So as you can see it right here that we are not getting complete coverage, and the reason being is that the pin B4 is not getting a hit. So why is that happening? As you can see it right here that we did provide 6 consecutive stimulus values, and those values are 16. Still it is not recording any hit, and it is because of the fact that this particular cover group will only sample whenever it detects any change in its sensitivity list, and A is one of its sensitivity list signals. And even though you are providing 16 for 6 times in a row, the value is not changing, it is same. For that reason, it is not sensing any change inside its sensitivity list, so this cover group is not triggering after the first 16, because the value is not changing. So for such kind of scenario, there are two possible solutions. The first one is that uh, if your design is a sequential logic, if it has a clock, you should make the clock as a event, as a triggering event rather than the signals. So regardless of whatever the signals are, even if it is getting repeated, it will get sample because it will trigger after every posage or negage of clock. But for this particular example, this is a simple combination logic which does not have any clock. Uh, we can just go ahead and do the manual sample using the sample method. So what I will do, I will just make some modifications right here. I will use the handle of my cover group, which is CAY, and I will call the sample method after every 16 so that this transition gets sampled and we get a hit for this bin. And I will also do that for the remaining 4 stimulus. So now it should sample the transition of 16 to 16 and so on. And this time this bin should get a hit. So let's find out. I will go ahead and simulate the code. So as you can see it right here that this time, since we are manually sampling the stimulus, the bin is getting a hit and our coverage is 100%. So using this method, you can just record multiple occurrences of a single value. So let's move on to other kind of repetition beans, and this one will have a range of repetition. So for this example, let's say I still want 16, and this time instead of providing a single value like 6, which I have given right here, I will provide a range. So let's give the range from 3 to 14. So this particular bin will get a hit if 16 gets repeated uh, anywhere from 3 times to 14 times. So it is very similar to this set of transition bins where there will be multiple cases, and if any of those cases is recorded, it will get a hit. So if 16 gets transitions or 16 occurs for multiple times, let's say it occurs for 3 times, this bin will get a hit. And if it occurs for 4 times, this bin will get a hit. And same goes for like the other values till 14. So since as per our stimulus, we are already providing 16 for 6 times in a row because of our previous bin, it should record multiple hits for the bin B5. So let's find out. I will go ahead and just simulate the code. So as you can see it right here that bin B5 is getting 4 hits, and it is because of the fact that 16 is repeating for first for 3 times, then it is repeating for 4 times, which accounts for 2 hits, then it is repeating for 5 times, which accounts for 3 hits, and simultaneously it is repeating for 6 times, which accounts for 4 hits. So for that reason, we will get 4 number of hits for the bean B5. So such kind of repetition beans are categorized as range of beans. So if 16 occurs anytime from 3 to 14, this bin will get a hit. So that was all about repetition beans. So in our next video, I will discuss some other special kind of beans, which is a sort of mixture of transition bean and repetition beans. So stay tuned for more. Thank you so much.